السلام عليكم ورحمة الله وبركاته. أعزائي طلاب الصف الثاني الثانوي. Today, inshallah, we will study operations on functions and the composition functions. First, operations on functions. If f1 and f2 are two functions whose domains are d1 and d2, then f1 plus or minus f2 of x equals f1 of x plus or minus f2 of x, and its domain is the intersections of the two domains equals d1 intersection d2. Letter B, f1 times f2 of x equals f1 of x times f2 of x, and its domain d equals d1 intersection d2. Letter C, f1 over f2 of x equals f1 of x over f2 of x, such that f2 of x doesn't equal 0, and its domain d equals d1 intersection d2, difference zeros of the denominator, zeros of the function f2. Exercise, if f is a function from r positive to r, where f of x equal 2x power 2 minus 7x plus 5, and g is a function from semi-open interval negative infinity and 4 to r, where g of x equals 2x minus 5, find f plus g of x, f minus g of x, f times g of x, f over g of x, then state the domain of each of them and calculate f plus g of 3, f minus g of 0, f times g of negative 3, and f over g of 1. Since d1, the domain of the first functions, is positive r, semi-open, open interval 0 and infinity, and the d2 is the domain, and the domain of the second function is semi-open interval negative infinity and 4. We can represent the two domains in the number line, and the intersection of this domain is semi-open interval 0 and 4. So f1 plus g f plus g of x equals 2x power 2 minus 7x plus 5, that's the rule of the first function, plus 2x minus 5, the rule of the second functions, and its simplest form is 2x power 2 minus 5x, d equals d1 intersection d2 equals the semi-open interval 0 and 4. f plus g of 3 belongs to the domain of some function. It is equal to 2 times 3 power 2 minus 5 times 3. In the simplest form, it is equal to 3. f minus g of x, it is equals 2x power 2 minus 7x plus 5 minus open bracket 2x minus 5. In the simplest form, equals 2x power 2 minus 9x plus 10. The domain equals d1 intersection d2 equals semi-open interval 0 and 4. f minus g of 0 is undefined because 0 doesn't belong to the domain of the function f minus g. f times g of x equals 2x power 2 minus 7x plus 5 times 2x minus 5. It's equals 4x power 3 minus 24x power 2 plus 45x minus 25. And its domain is the semi-open interval 0 and 4. To find the value of f times g of negative 3, it is also undefined. It belongs to the domain of the function f times g. Number 4, f over g of x, it is equals 2x power 2 minus 7x plus 5 over 2x minus 5. We can simplify by factorizing the numerator into two factors, 2x minus 5 multiplied by x minus 1 over 2x minus 5. In the simplest form, it is equal x minus 1. And the domain of this function is semi-open interval 0 and 4. Difference set of 5 over 2 is the zeros of the denominator before reducing. F over g of 1, it is equals 1 minus 1 equals 0. Exercise number 2. If f and g are two functions where f of x equal x over x plus 1 and g of x equal x plus 1 over x minus 2, find f plus g of x. Number 2, f minus g of x. Number 3, f times g of x. Number 4, f over g of x. Then state the domain of each of them and calculate f plus g of 3, f minus g of 2, f times g of 3, and f over g of negative 1. Solution. The domain of the first function is fractional function. Its domain are different zeros of the denominator, are different set of negative 1. Also, the domain of the second function is r different set of 2. So we can represent these domains as the number line as you see in the opposite figure. And the intersection of the two domains is r different set of negative 1 and 2. To find the f plus g of x, it is equals x over x plus 1 plus x plus 1 over x minus 2. We can unify the denominators to become x plus 1 times x minus 2. And the simplest form of the numerator is 2x power 2 plus 1. The domain of these functions is r different set of negative 1 and 2. Number 2, or to find the value of f plus g of 3, 3 belongs to the domain. So it is equal to 2 times 3 power 2 plus 1 over 3 plus 1 over 3 minus 2. And it is in the simplest form equal 19 over 4. Number 2, f minus g of x. It is equal x over x plus 1 minus x plus 1 over x minus 2. In the simplest form, it is equal to negative 4x minus 1 over x plus 1 times x minus 2. The domain equals r different set of negative 1 and 2. To find f minus g of 2, it is undefined because 2 doesn't belong to the domain, r different set of negative 1 and 2. F times g of x, its rule equals x over x plus 1 times x plus 1 over x minus 2. In the simplest form, it is equals x over x minus 2, and its domain is the intersections of the two domains, that is equals r different set of negative 1 and 2. F times g of 3, its value is 3. So f over g of x equals x over x plus 1 divided by x plus 1 over x minus 2. In the simplest form, it's equal x multiplied by x minus 2 over x plus 1 all power 2. And the domain equals r different set of negative 1 and 2. F over g over negative 1 is undefined because negative 1 doesn't belong to the domain of this function. Exercise number 3, if f1 of x equal root x minus 2 and f2 of x equal root 5 minus x, f3 equals x minus 3, find the rule and the domain of each of the following: f1 plus f2, f2 minus f3, f1 times f2, f3 over f1, f2 over f3. Solution: x minus 2 is more than or equal 0. So x more than or equal 2. The domain is semi-closed interval 2 and infinity. And the domain of the second function, 5 minus x more than or equal 0. So x less than or equal 5, and the domain of the second function is semi-open interval negative infinity and 5. While the third function is polynomial, so its domain is R, and we can represent these functions and the domain of these functions equals R. So f1 plus f2 over x of x, 1 plus f2 of x, its rule equals root x minus 2 plus root 5 minus x, and the domain is the intersection of the two domains equals the closed interval 2 and 5. f2 minus f3 of x equals root 5 minus x plus 3, and its domain is the intersection of the two domains of t1, t2, and t3. It is equal semi-open interval negative infinity and 5. f1 times f2 of x equals root x minus 2 times root 5 minus x, and its domain is the closed interval 2 and 5. While f3 over f1, its rule is x minus 3 over root x minus 2, and its domain is the intersection of the domains d1 and d3. It is equal to semi-closed interval 2 and infinity difference of 0, and it means equals open interval 2 and infinity. f2 over f3 of x equals root 5 minus x over x minus 3. Its domains equals semi-open interval negative infinity and 5 difference of 3. Exercise number 4. If f1 is a function from R to R, where f of f1 of x equals 3x minus 1, and f2 function from the closed interval negative 1 and 52 to R, where f2 of x equals 3 minus 2x, then grab the function f1 plus f2 of x and reduce its range. Solution: the domain of the first function is R, while the domain of the second function is the closed interval negative 1 and 2. So f1 plus f2 of x equals x plus 2, and its domain is the intersections of the two domains is equals the closed interval negative 1 and 2. To find the range of this function, you have to grab the functions, and we can construct a table like this and substitute out the value of x by negative 1, 0, and 2, and determine the corresponding value of f1 plus f2, and we can plot the points that represent the ordered pair and join between them to grab the function f1 plus f2 of x. To find the range of this function, it is the set of all y coordinates of the points on the curve. It is equal the closed interval 1 and 4. Now we will study the second item in our lesson, composition of the function. If f and g are two functions, then f after g of x or f of g of x is called the composition of the function f with g, f composed g, or f after g. where its domain is the set of values of x in the domain of G, which make G in the domain of F. Sorry. The domain of F after G of X is set of X such that X belongs to the domain of G of X and G of X belongs to the domain of F. And we can take exercise to explain this concept. F of X equal to X plus 1 and G of X equal X power 2 minus 3. Then find each of the following composition function: F after G of X, G after F of X, F after F of X. To find F after G of X, it means we write the rule of the function F 2 times and substitute about X by the value of the function G of X 2 times X power 2 minus 3 plus 1. In the simplest form, it is equals to X power 2 minus 5. G after F of X equals 2x plus 1 all power 2 minus 3, and in the simplest form, it is equal 4x power 2 plus 4x minus 2. Number 3, F after F of X, it's equals 2 times 2x plus 1 plus 1, and the simplest form equal 4x plus 3. Thank you for listening, and I hope to see you next session. Inshallah. Wassalamu alaikum wa rahmatullahi wa barakatuh.